check this out. So I was testing the speed of the parser, and wrote a little benchmark script here, just a tiny bit of Ruby with an array and a hash and some other stuff, a class and a module, running it through both the existing Ruby parser, the gem that we're trying to replace, and then running it through our parser, the one we've been writing in C++ using a parsing expression grammar, and I've just looped it 1,000 times. So here it is running with the Ruby gem, and it takes 1.7 seconds. And we're going to compile it with Natalie, cheat a little bit, and get rid of the compilation time, but then we're going to run it through time. And 3 seconds. And it's worse if we do this 10,000 times. It's really bad. It's 12 seconds versus 2 minutes or 2.5 minutes. So that's a no-go. This is not going to work. This is failure. I have failed to make a parser using a parsing expression grammar. Now, I've profiled this, and the bulk of the work is not in my code. It's in the library that we're using, and I'll show you the library. Here it is. So this is the library. It's a parser generator using a parsing expression grammar, and it was fantastic. I loved the syntax. It did exactly what we wanted, but it's just too slow for what we're trying to build. Now, if you are building a configuration parsing bit of code, or your own little toy language that you just want to play around with, or whatever, I'm sure this library would work great. However, for what I'm building, I can't have it be 10 times slower than what we already have, which isn't blazing fast already. So let's start with throwing it away. So you see all this code, all these rules that we made, and you sat here with me through some of this. So this is gonna hurt. This is going to hurt. All the way down here, strings and hashes and arrays and everything else, and I'm just gonna delete it, and now we have an empty file. And we'll just return a nil just to make everything happy. But we're not happy, we're sad. So just feel this moment with me, this pain of writing code and then throwing it away. It hurts. But we're not going to give up. This is, after all, not a project where we have to ship by a deadline. This is not a company paying us money to finish something on time. In fact, nobody cares except me and maybe you. But nobody cares when it ships. It just needs to be right. And so I'm going to start for the month of December. I'm going to start on a new project, which is to write a parser by hand, not using a parser generator, and see how good we can do. And we're going to benchmark as we go. And if things start to go off the rails, then hopefully I won't get as far along as I have with this project. So that's the intro, and I am going to start over with the parser and write something that it may not parse all of Ruby. I've already decided, because Ruby is a very intricate language and hard language to parse. But I figure if it can parse 80 to 90% of the Ruby files out there without modification, then I'll be happy. And we can maybe not focus on the more obscure or esoteric sort of parts of the Ruby syntax, and just go for 80 to 90%. And I think that's something reasonable that I can do. So let's get started. Well, hello, welcome back to Language Hacking, and we're working on our Ruby parser for the third time, starting over. The first project was trying to get the Ruby parser gem that we did not write, getting that to compile with Natalie, and sort of bootstrapping our system from an existing Ruby. Take two was using a parsing expression grammar, and that has, as you've seen, has failed. spectacularly, and we deleted that code. And now take 3 is we're going to write a parser by hand. And we'll see what happens. And I've already started on the Lexer. Here is the Lexer test. Here's the test for it. And so we have all the keywords for Ruby, which I got off of a list somewhere. And then we have a test for that. We have, it actually knows how to Lex and tokenize the difference between a division slash versus a regular expression slash. And this took me just kind of playing around with Ruby and figuring out what Ruby does, and so trying to mimic that. And so, you know, taking this string of code and turning it into an array of objects. And when it's turned into Ruby, these turn into hashes, but internally they're all structs. And yeah, so just Lexing that. And so we've got some operators and numbers and negative numbers and so on and so forth. Strings, arrays, hashes. Now, strings are tokenized as one thing. You get back a string object. Arrays are tokenized the individual symbols, and the next step in the parser will have to turn that into an array. And the same with hashes. It does the same thing, or just turns it into the individual symbols, like the squiggly, the curly brace, and then the foo, and the little hash rocket is another symbol, and so on and so forth. It tokenizes class variables, instance variables, global variables, and I've been working on this for a little while now, and it's taking shape. It's very fast, and I think this is going to be a good start to our parser. And so in this short video, I just wanted to maybe add one thing to it. I did notice that we don't have an operator for the what is it called in Ruby? I've lost the name for it. So if you have something that's a nil object and you do foo ampersand dot bar, it will, no, so see, like if I just do bar, it's going to say there is no method bar. But if I say foo ampersand dot bar, then if the left side is nil, then it just immediately returns nil. And you can chain them together like this, and you'll always get back nil. So it's the safe navigation. I think it's called the safe navigation operator. And so we should be able to tokenize that, and that shouldn't be too hard. So we'll just stick it on the end here. And this should tokenize as one symbol, but since I haven't written the code for it, it's probably going to tokenize as an ampersand and a dot separately, 2 separate symbols. So let's just verify that. So we'll do Ben Natalie test, Natalie Lexer test. And here is our error right about here. It's a little bit hard to read. I need to split this up. But you can see there's 2 separate symbols here. And so this will be a good chance for me to show you how the Lexer works. So it's all in the header right now. I'm not sure if I like that, but it all fits in the header file for now. And so we just need to find where are we recognizing this ampersand symbol, and it's right here. Oh, I don't know what. There we go. So this is just a whole bunch. Let me go up to the top. It's a whole bunch of switch statements, and it's just scanning through the string, looking at individual characters and seeing what they are, and then switching on those characters. So here is the deepest I believe it goes for a single operator is equal, equal, equal. So in this case, it sees an equal sign, advances the cursor, and then it sees another equal sign, advances the cursor, and it does it a third time, and then it says, okay, so this is the triple equals operator in Ruby. And then if it didn't see that, then it must be the double equals, and so on and so forth. So actually, I don't even see. Oh, right, because it could be equal, like the hash rocket, so the equal sign and then the greater than, equal tilde, and then if not, then it's just a plain old equals by itself. And so this is just a whole bunch of nested switch statements, which I've been reading, and this is a valid way to do a Lexer, and actually not a bad way to do a Lexer. It's a little verbose possibly, but it is fast and it's easy to read and understand what's going on. So let's just work on the new operator that we want to add. We want to advance the cursor because we want to consume this dot, and then we want to return a new token. And this token is going to be safe navigation. I believe that's what it's called. Let me just make sure. Ruby safe navigation operator. Yeah, that's exactly what it's called. So let's just we'll just call it that internally as well. And we record the line and column number of where we found the operator or the token. And so we'll use that later for error reporting and stuff like error handling. And so we need to add this as a token type. So up here at the top, we have our token and token types. And we'll just add it. I've been trying to do it alphabetically. Hopefully I've been able to do that. And then we also need to handle it in this switch statement down here, which is, this is the toRuby method. So for my tests, I need to turn it into a hash so that I can run our tests. And so that's what this does. This won't be used in the parser, I don't believe, just for the tests. So this it's okay that this is going to be a little bit slow, turning it in each token into a hash. Totally okay, because it's just for testing. But so I need to go down here to safe navigation. I'll just copy this. We'll do safe navigation, and we're gonna actually turn it back into. Oops, that is. I don't know why I just typed that. Turn it back into the token that it is, and then we'll run our tests again. We need to run make. And there you go. So that's a quick example of how to add a new token. We added the token type at the top, and I wonder if there's anything else I should show about this. I think the code is fairly self-explanatory. Nothing too crazy going on. For strings and symbols and stuff, we have an additional. It'd be easier to show you over here. We have an additional key in the hash called literal that returns the actual value of the, in this case, identifier, like a variable name. So that's that. We have the line and column, like I already mentioned, is available. And the white space, this white space stuff is pretty cool. Skip white space. I had to obviously want to not count white space as anything, but there are times where white space matters, and so if white space is found, then we return true from this method, and we set that to a member variable here, member property. White space precedes, and this is used when, is it just used in the one place? Yeah, it's used on the slash because the slash is tokenized differently if there's space before it, or versus if there is not. And that was really fun to figure out how to do, and I think I can show that here. This is foo followed by a regular expression because there's a space, so it assumes this is an argument to foo. But this one has no space, so it tokenizes it as foo divided by 2. Yeah, that's the case. We needed to know the white space. This one space right here, or lack thereof, changes how things are tokenized. So I thought that was an interesting way to solve that problem, and that's our Lexer, and it works really great, really fast. I don't know if let's just do this. We'll just call it L. and that's running in 0.02, and we're doing a decent number of tests here, and that is in stark contrast to now I know it's not parsing, it's just lexing, but our parser test with 148 lines of code, so not nearly as many as our Lexer test, was running. It was taking 4 seconds or something to run, and our Lexer, it's promising to me that our Lexer is 0.02 seconds. So hopefully we'll get to stay on the speedy side of things. And that's it. I think that's all I wanted to do for this video. My goal is for the month of December to do a video every day. Oh, I probably have jinxed myself by even saying that, but I'm going to definitely work on Natalie every day, and if I can, I'm going to make a video about it. And I'm going to be working on the parser, and this is take 3 of the parsers, so wish me luck. And every bit of encouragement you can give me, I will take it. And if you have advice, words of advice, I will take that as well. And as always, thanks for being an encouragement to me and helping me with this project. All who've contributed, either code or bug reports, or even just saying, hey, you're doing a good job. I like that too. Appreciate you, and I hope to see you in the next video.